everyone. Welcome to this BAKERpedia seminar, all about bringing objectivity into the plant and achieving consistent quality in your bakery with objective data. I'm Mark Flurka, your host for today. This seminar is brought to you by KPM Analytics. KPM Analytics supplies instruments that measure critical quality parameters of incoming ingredients, analyze products during the baking process, and ensure final product quality. Their comprehensive range of analyzers are used by food producers throughout their production to improve efficiency, ensure quality, and protect their brand. KPM Analytics is backed by 100 plus years of experience developing advanced products and processes for quality assurance and process control in baked goods manufacturing. Today, we are joined by Lena Boskbiana. Lena Boskbiana has an education in engineering and in food science, specialized in the cereal industry. She works for Chopin Technologies, part of KPM Analytics, since 2014. For more than 9 years, she occupied different positions and now manages the food products and applications team, whose role consists in ensuring the application development and promotion of Chopin products. They provide personalized solutions to customers willing to improve control of their products and processes. Lena's responsibilities also include standardization of the developed method, working closely with various associations such as ISO, AACC, also now known as Cereal Grains, and ICC. Lena will now share a presentation. Welcome, Lena.
Well, thank you very much, Mark, for this kind introduction. So let me share my screen. Let's get started again. Thank you very much for having me today. This is always a pleasure to participate to BAKERpedia's event. Always very interesting to be learning with you. And today we are going to speak about a very interesting topic, how to bring objectivity into the baking plant. So the idea is to assess a little bit the situation, to think about what we did in terms of quality control, how our world has evolved, and what we can do differently, or at least a few ideas on how to improve our current methods. So let's maybe start with the beginning and with a little bit of history of the milling and baking evolution from 100 years ago. And that's really fascinating because in 100 years, our industries have changed tremendously. We have gone from a very artisanal know-how with craft bakers, craft millers doing their job manually, to highly automatized lines of production with very high throughput. And so this means something to us today, because the fact is that today we still rely on the same instruments, on the same quality control tools that we developed 100 years ago. But at the time we saw that the technologies, the challenges, they were completely different, and the wheat quality has evolved as well. It was much weaker around 100 years ago. Those laboratory tools that were developed 100 years ago, such as the farinograph, the enverograph, they were mostly used by millers, not to produce the most adapted flour to the baker's needs, but rather to ensure consistency. It was maybe not the perfect flour, but at least it was always the same. That was the point. And because if something was not fitting 100% the process, at that time, bakers, they could count on master bakers able to correct, able to touch the dough, able to make it work, even if the flour was not 100% fitting the needs of the process. But this experience is now disappearing a little bit from the industry. And this tendency, it has been accelerated since COVID. Additionally, baking industry is becoming more complex. We have seen that, high levels of automatization, but also we now need to produce much more variety as we needed before. Now it's no longer just about the standard biscuit. It's about the gluten-free biscuit and the whole wheat biscuit and the low-fat biscuit or keto biscuit or whatever. But there is a need for much more raw materials, much more flours, much more variety, much more additives as well, enzymes that have grown a lot as well in the past 100 years. And finally, maybe last challenge, a big one for the industry is that the final consumers, us, when we go to the supermarkets, we are becoming more and more demanding and we are becoming more and more visible at the same time. Because if I go to the supermarket and I buy a pack of crackers and inside they are all broken, I can take a picture, I can post it online, I can make a big noise. 20 years ago, that was not possible. So I only have like 26 followers, but that's not the point. The point is that we can make a big noise, much more than before. And so baking industry, they have very small margin of errors. But the point is that this situation is not sustainable anymore. And this is actually very well illustrated by a couple of facts. The first one is that we learn what we learn at school, and what we can find in the literature are common parameters to measure the quality of flours, and those standard parameters are becoming a little bit misleading. What you can find in the literature, what you can find in the baking books is that, for instance, and this is just an example amongst thousands, for making a good sandwich bread, then you need a flour with a protein content between 10 and 11.5%. That seems simple enough. You just need that, and you'll have a nice sandwich bread. Well, we did the study actually. We analyzed 150 flours from all around the world for protein content, and we made the sandwich bread. And well, you can have two flours, one with a protein content of 10.1% and one of 11.1%, which are in between this range, and still end up with two very different results. So I'm not saying that protein content does not matter. I'm just saying that it does not tell you the entire story, that maybe here we're missing something. And also there is a very important factor, is that to make a good sandwich bread, okay, but which one? To make a good pizza, okay, but which one? A pizza coming from Chicago or a pizza coming from Napoli? That's not the same pizza. That should not require the same flour. My point is that there is not one that is better than the other. It's just that the final product depends on the final user's preferences. And in addition to that, to produce two types of same Chicago pizza, you may have two different baking plants. And that means different recipes, different processes, maybe longer mixing times, maybe different machines at different temperatures at different times. And there is a human factor in the end that also plays a role in the results. And so what we believe here is that flour quality should not be as simple as between 11 and 12.5 and you do sandwich bread. It should be specific to each baker, taking into account its final product and process specificities. So when we find such advice that for making a good pizza, then you need a flour with a strength, a W value with the alveoli between this and that, yes, that can give you an idea, but it does not integrate the many differences between the baking plants. And so it does not really, it has really little chance to correspond to your specific reality. And this is very well illustrated by this final fact, is that we asked the question to bakers. We did a survey on LinkedIn, and we asked a very simple question. Does it happen that flour, despite meeting all laboratory specifications, still gives issue during production? And the answers were yes, 96% of the time, with some people experiencing issues as frequently as like 1 every 10 deliveries, which is which can represent a lot of money in terms of non-conform products that you have to reject, or maybe difficulties at the line. Interestingly enough, the 4% answering no, it never happens. When we looked up at who they were mostly academics. So the one putting in the books that it should be between 10 and 11.5. So it's just very theoretical. It does not, again, represent one's reality. So our idea is to change a little bit what we have been doing for 100 years, because it is not longer sustainable to change a little bit what we do and to take back the control at the baker's level. And it all starts by the end product. So here it's a burger bun, but it can be a pizza, it can be a biscuit. The strategy is a little bit the same. The idea is that what we do today here to assess the quality of this final product is visual checks, mostly by operators taking products from the line, and also punctual checks like every half hour, every hours, to measure the weight, the dimensions, and the color of the product, like 10 of them. And this is good, but it doesn't give you the performance of the entire production. And if the operators are taking, removing products from the line, you don't necessarily know why. And so knowing what to correct is extremely difficult. Here, we can improve by putting objective system that can control the entire production on the line of production. And that can put numbers on what is a good product in terms of dimension, in terms of color, thanks to vision inspection systems. Then we can go back forward one step and look at the dough. The dough quality is very important to ensure a good final product. And today we ensure that the dough is good thanks to baking experts touching the dough, stretching it, looking at it, and applying corrections based on their experience, like modifying the water absorption or putting a little bit more magical powder. Well, this is good, again, but this expertise is disappearing and is extremely difficult to transmit to someone else. It's in the end quite subjective. And so here the idea is to put numbers on this expertise and to objectively assess what is a good dough during the process, thanks to rheological instruments, thanks to, here I'm going to develop the mixer lab. And finally, before the dough, what plays a very big role in the characteristics of the dough and can influence the final product a lot is the flour. And here today, what we do is that we have a lot of different specifications: farinograph, extensograph, glutamate, alveograph, protein content, ash content, folding number, and so on. And because we have all of that, we hope that it will work. The idea here is to focus on what really matters and to really design specification based on what works for your specific product. And to do that in a way with a tool that will help you communicate efficiently with your millers. So that's a little bit the promise, well, or the idea, the strategy that I'm going to develop. So first, starting with the end product. Here again, the idea is to have a complete quality check of the final product. And you can do that either off the line. So here you're going to select your 10 products as usual, but you're no longer using a caliper, a moisture meter, a colorimeter, a weighting scale. You use an all-in-one product that is able to measure the shape, the color, the bottom color, the top color, the height, the symmetry of the product. That allows you, well, first, it's very useful for R&D projects. Like if you need to modify recipes, then you can easily optimize product quality as a function of what you're looking for in terms of final product characteristics. And you can also obtain objective data to determine the tolerances of your production process, to then apply them at the line of production using a full at-line system that you place at the end of the line, and that is able to measure the same characteristics. So again, dimensions, colors, symmetry, height, and so on, but to perform a complete quality check. And of course, depending on the product, then the key aspects of the final product will not be different. So we will not be measuring the same thing. For a baguette, for a bun, for a bagels, for a tortilla, or whatever, we can adjust according to your specific production and also to your specific needs. If you need to spot a very small black spot behind your product, this is something that we can think of. I mean, we can tailor it specifically for your needs and for your challenges. And here we can also incorporate an automatic rejection system to this vision system. So you set up specification to what is good, and everything that is not good is automatically rejected thanks to a system that is tailored to your product as well. So we can see here various examples for cookies and crackers. So this is thanks to the air nozzle here. Here we can see it for, I think this is a, yeah, here this is for a pizza crust. And well, the idea is that the system varies according to the end product, and you can also apply that to previously in the line of production to frozen dough, for instance, here, frozen baguettes. Oops, how do I, oops, okay. So now we have control over the final product. We need to move back a step and to focus on the dough. So dough characteristics are very important, and you are the one as bakers who know what steps are the most important to obtain a good consistency and to have a process that runs smoothly without stopping, without big problematics. And that relies a lot on the consistency of the dough at different key steps of the production. Again, that depends on each production. That can be after mixing, that can be before proofing, just before oven. The idea is to determine those key steps and to take a sample of dough from the production line and to place it into a rheological instrument that is going to be able to assess objectively the consistency of the dough at this step. So here, this is how we do it with the mixer lab, which is an instrument that measures the consistency of the dough. So we take a sample of dough, we weight the amount that is interesting for the test. So here it's 75 grams. You shape it to facilitate its introduction. You place it into the mixer lab and you get a reading that corresponds to the consistency of the dough at this instant. So this is the kind of information that you can get. It's only 2 minutes testing, so that's very quick. So you can react very quickly. And here, this is a study that we have made for a bagel producer. We measured the dough quality at the end of mixing, and we monitored the production, which dough was giving a good final product. So all the green curves here, they were giving a good final product. And all the red, they were giving a final product that was not conform, specifically for the hole that was deformed or not apparent enough. The idea is that here you can set up specifications to what works with you at different steps of the process, and therefore not wait for the final product, because between mixing and the final product, sometimes you have 2 hours, you have 10 hours, and sometimes even more. So the idea is not to lose those 10 hours, is to know from the start what is going to be good or not, anticipate and correct. And the mixer lab has a very interesting ability also to heat up and cool down the dough. And by doing that, we access a world of new information. So here, this is an example of the evolution of the consistency of gluten-free, no, not gluten-free, sorry, crackers. It was not gluten, the standard crackers dough. The evolution of standard crackers dough during resting. So we took a sample of dough every hours and we saw where was the difference. And again, we have a lot of information, but the idea is that we saw a tendency to have a weaker consistency during resting. And this is most likely due to the proteases that is in the formulation, having an action during resting phase. Also, we saw a lot of impacts on the starch part, so when the temperature is high. And here again, a decreasing of the consistency, indicating that maybe amylase also were having an action at the same time. The point is just that here we access a lot of data that we never seen before, and so probably a lot of value. that we are not fully capable to analyze yet, but that's just the beginning. And once we control the dough, then again, we can move back another step and focus on the flour. And here, thanks to the Mixer Lab, you can also develop a specific profile, what we call a profile for your product. So maybe here we need to come back to the basic a little bit of the Mixer Lab, because after all, this is an instrument that was designed to analyze flour and to give a lot of information on flour. So here you can see the Mixer Lab, which is basically a mixing bowl and a water injection system. And when you inject water into flour, then you can measure the water absorption capacity of the flour, and you can measure its mixing behavior, development time, stability. And where it gets interesting is that we are also heating up the dough. And here we can see how the gluten reacts to this increase in temperature, which has a big impact on the volume of the final product. And then we also see all the characteristics of the starch, such as here, the gelatinization, which impacts the structure of the crumb. We can see the impact of the amylase activity, which will also impact the color of the final product. And finally, we decrease the temperature, and this allows us to see starch retrogradation, which will impact the stalling, the shelf life of the final product. So the point is that here, in one unique test, we access a lot of information on the flour, not only protein, but also about starch, which is 70% of the flour, and that we basically don't control. So, well, additionally, you do that automatically. So it's 5-minute preparation. You launch the test and you're good to go. It works with only 50 grams of flour, which is a reasonable amount. And it's an internationally recognized method, a standardized protocol at various levels, at ISO, at ACC, 0 grains, and ICC, and so on. And so we have this curve in the end that goes up and down, and that is full of information. And the idea is that we can also simplify this curve in a profile in different indexes, in 6 indexes that are graded from 0 to 9. And thanks to that, we can visually develop target profile for various end products. So this is what you see here. The green area would correspond to the acceptability of a specific process. And so you can easily spot which flours are in and which flours are out. You can develop specific profiles, again, by just observing what is working for you or not. This flour works for my process and allows me to have a good final product, and this one does not. And you can easily see where is the difference. So of course, for different final products, you have different profiles. That makes sense. You need different flour quality. And also that illustrates very well what I've been explaining earlier, is that here, this is the same company making the same type of final product in different countries. But in those 3 countries, because they don't have the same plants with the same machine, some are old, some are new, they don't have the same temperatures, they don't have the same flour providers, well, they don't require the same flour quality. And so again, here you are able to develop something that is specific to you instead of relying on an information that maybe will fit this specific plant, but not this one or this one. And in the end, so this is an idea of the results that we can get. Here, these are the results of a study that we did with a Brazilian manufacturer of pan bread, where we developed a profile and we followed the results on new incoming flours, all new incoming flours for a month. So during this month, they received 21 flours and 15 were evaluated okay in production. Those are those black flours here. And 6 of them were not okay. So those are the red flours. And so here is if the flour was in or out the developed profile for each specific index. The good news is that all bad flours were correctly identified, as they were out for at least 3 indexes. Most good flowers were also correctly identified, as there were 100% in, and there was this area of uncertainty, because the mixed lab, after all, is not a magical ball. It's not a magic ball, it's just a tool. But here, you are able to take informed decision. The example of this company is interesting because before they were performing baking tests on all incoming flour to see how they were performing. Now they are able to focus on where they need to focus. All the in, they are accepted. We know they are good. All the flowers that have 3 indexes or more out, they are out. They are rejected. We don't speak about that. We don't need to test it. They are bad. But you can focus on those 3 remaining ones. And also what is very interesting is that the first 2 indexes relate to the absorption capacity and to the mixing behavior. So development time, stability, and those parameters are pretty well under control thanks to the traditional tools that we already have, the farinograph, the alveograph, the glutamatic, and so on. Where we can really see the difference is because the mixer lab is able to heat up and cool down. And so here we can discriminate. And this can also work with a variety of raw materials. We can see the impact of vital glutens, we can see the impact of sugar, of salts, and up to the most complicated raw materials. We have made tests on pulses, we have made tests on pre-gelatinized wheat, on potato flakes, on complex formulation, and recently on cheese. So we can make a lot of different things with this instrument to control your raw materials as well. That's the point. In conclusion here, the traditional model that we are working with today is basically to make a bunch of tests, farinograph, alveograph, folding number, glutamatic, NIR, ash content, and so on. And because we do all of that, and because we also rely on data that we have seen on the literature or on things that we have heard from a consultant that will tell you that this is a good flower because I read it somewhere, well, this leads to 96 unhappy bakers. So we think that here there is a room for improvement, and by following a different strategy, which is to guess less and measure more the final product characteristics and subdivision inspection system to understand how the dough evolves during the process thanks to rheology to define specifications at key steps of the production, to define what is a good flour for your specific needs, and to give the miller robust specification that allows him to focus on what really matters to you. There is nothing less frustrating for a miller than to make a bunch of tests and in the end be on the phone with an unhappy baker that says that your flour is not working. Here again, you can see where you need to have an action because you focus on the entire quality of the flour, and you know what really matters to you. Plus, and I will finish on that, our world have evolved a lot. We have seen that, but this is not done. This is not done changing, evolving. And the next revolution is most probably artificial intelligence. And food of artificial intelligence is data. Here with this system, you gather objective data at all points of your process. And so you are ready for tomorrow's revolution.
Awesome.
So,
Thank you.
Thank you.
Thank you very much, Linia. That was awesome. That is so informative. And as I watched you presenting, I so wish I could have had a vision system in my lab for product development. That would save so much time. It's unbelievable. I mean, we had a lot of good tools and instruments, but the thing is that it does a lot of what would take hours, to collect all of the information and stuff in like the matter of 5 minutes sort of thing, right? And don't forget, if you're watching this video as a recording, like and subscribe so that you don't miss any of it. Is amazing to me what the vision system can do. Every time I learn a little bit more, it's just like poof, right? It's like, if I had had this 20 years ago, right? Um, but it's just incredible. I think we can start to maybe get to some of the questions and see how much we can fit in before the end of the seminar.
So I think that here you are referring to the spider web, to the profile that we get in the end. So basically, this is just a way of translating the Mixolab curve, which is measuring a lot of different parameters, as we have seen, the mixing properties, the starch properties, and we put that in a simple way. And so each point will correspond to a big characteristic of the flower, a general characteristic of the flower. We have 1.4 absorption capacity, which is graded from 0 to 9. So basically, if you have 8, you absorb way more than if you have 2. And then you have mixing index. And if you have an 8, that means that you have a flower that resists very well to mixing. On the contrary, if you have a 2, that means that your flower does not resist very well to mixing. And you do the same for the characteristic of the gluten when temperature increases, for starch gelatinization, for the amylase activity, and for the retrogradation, and you have your profile.
Yeah, and with all of these things, bear in mind it's not something that KPM or anyone else can magically pull out of the air, that you say, oh, I'm in Trinidad and I'm using flour from a mill in Puerto Rico. It's not like they can open a file and say, here's your curve, right? It's got to do with establishing a foundation, a basis of what is a good product. So if you use flour X to make your product and the product is good and you take all of those measurements, it gives you a basis and you build the information around that basis as to what the critical points are. Because otherwise like when Linia showed the 3 different countries, it's not by somebody with a magic crystal ball, right? It's actually running flowers in those countries and on those products to get those results. And that's how you establish with any analytical testing. That's how you establish the basis of what's red light and green light.
Yeah, very good point. Thank you, Mark. Well, that depends on what you do. If you want to analyze flour, the standardized Chopin Plus test lasts 45 minutes, but it's 5 minutes of launching time for the operator, and then you're good for 45 minutes. Then if you're using the Mixolab at the line on dough taken at the line, you can design, and if you're only interested in the immediate consistency, like the reading of the baker, then you can decrease this time, like and do a 2-minute test.
It all depends on where and when the instrument is being employed.
Yeah, exactly.
Deployed. Yeah.
That's a very good question, because the Mixolab is often seen as a farinograph-like instrument, because yes, it is similar in some way. We are measuring the evolution of the consistency of a dough. And by such, we have information like water absorption, like development time, like stability. But with the Mixolab, we are also able to heat up and cool down the dough. And by doing such, we access a lot of information about how the gluten reacts to this increase in temperature, which is related to the final volume, at least that will impact the final volume as it relates to the oven spring. And also about the starch information. Starch composes 70% of the flour, and is not something that we can assess thanks to a farinograph. Here you also see starch gelatinization, starch, impact of amylase activity, and starch retrogradation. So you focus on, well, not focus, but you see much more about your flour than with a farinograph. Maybe to finish on this note, if you're still interested because you have built for many years a reference around farinograph data, the Mixolab is also able, thanks to a specific protocol, to provide farinograph data, like in farinograph unit and so on. So you can keep in touch let's say, with your historical data.
Yeah, and as we've always said for many years, even back in the good old days, Farino graph is only one point of information. It is not the be all and end all.
That's it, exactly, yes.
Ooh.
So a premix, you mean like all the ingredients, dry ingredients that you put in the mixer lab?
Yeah.
Well, yes, this is something that we have done in the past already for various formulations. We've done this work recently on gluten-free dry mixes for different recipes, for bread, for cakes, gluten-free cookies. We even put chocolate chips in the mixer lab. Well, that melts. But that's interesting. So yeah, we can do that. And in the end, we have a curve that is the resulting of all the components interacting together. But you can see if it changes. And if it changes, it will probably be different used by the same process. But here, if I know more about the objective, maybe I will be able to be more informative.
That's really interesting. Wow. Having worked for a bakery mix manufacturer for a long time, this would be incredible, you know, to be able to add it as a quality assurance component or as a complaint investigation component or things like that, because it gives you so much more information than just simply baking a cookie and saying, okay, it looks like a cookie, it's got the right width and the right height, okay, ship it, right? It'll give us so much more information that way. That's incredible.
So to build a robust mixer lab profile, the most important thing is your database, is the flowers that you use to determine what is good. And to do that, we recommend to have 20 good flowers that all behave correctly during the process and all give a good final product. These flowers must represent the entire acceptability, let's say, of your process.
If I can just to clarify, this can be 20 bags of flour or 20 shipments of flour, not 20 brands of flour.
No, not 20 brands, just like 20 shipments.
Yeah.
But the idea is if you go is to cover your entire viability. If you analyze 20 times the same flour, you will have a very tiny profile, and that will be extremely difficult to remain inside. On the contrary, if you are not following the performance of your process correctly and you include a bad flour, then you mess up your profile.
Yep.
But 20 flowers, depending on the companies, that can take a while. So what we always recommend before starting is start collecting flowers, keeping them in the fridge. And so when you start, you just make all of your tests at once. Making 20 tests is about 3 days. So that can be very quick.
That is amazing. Yeah, I mean, people who haven't worked with analytics a lot don't realize that 3 days is incredibly quick and short time period. That is phenomenal. I mean, in the flour mill in the old days with the other, you know, as far as Farino and everything else, it would take us months to collect that kind of data. And this is incredible. It's very promising.
Well, you need to collect your flowers.
Yep.
That's the main part. But yeah, once you
Yeah,
have
I mean, to collect a kilo of flour, it's not difficult or expensive to store. And then you just need a protocol to discard and rotate every 6 to 8 months or something like that. But that's the old guard, moisture protein, but there's so much more to a flour than just moisture and protein.
No, I definitely agree. Most of the time we can also see maybe well, we have color, we have folding numbers, we have a folding number is extremely important, of course, for sprouted wheat. We have a farinograph a lot, and then depending on the areas, you can also find alveograph. Sometimes a little bit of damaged starch, but starch remains the big absent usually. We don't control starch, and starch is 70% the flour, and it's highly functional.
Mm-hmm.
So that's the idea here, to also control protein, but also the starch.
Yeah, starch damage, gelatinization, all these things, that is really key. It's really critical. It gets missed way too often.
Yes, absolutely. All variety of gluten-free flours were tested with the mix lab. Rice flours, potato flakes, pulses recently. We have tested insect powders. As long as you get some sort of dough with a consistency, then we can measure it with the mix lab, which makes it a very versatile instrument.
Yeah, so that's great. So that's like combining the two separate questions here in a sense, is that it's like you can have a blend of ingredients like, say, rice flour, xanthan gum, locust bean gum, and so on, and that is your gluten-free flour, so to speak, as a consumer would call it, and you can test and get information on that from the Mixer Lab and get the predictability of how that may perform in a bread type system, for example. Right?
Yeah,
Very
that's,
good.
you see how it relates in comparison to wheat flour, for
Yeah.
instance.
Mm-hmm. Absolutely. Yeah. Should be is a rather arbitrary question, because again, going back to what Lena was discussing earlier in the presentation, the quantity of protein is not necessarily the main indicator of performance. Um, uh, Crackers tend to generally be pretty low protein, is one of the things I would say. But it all depends on regionality, and that is because of growing conditions of the wheat, because let's not forget we're dealing with something that is produced by nature. And then it is also the practices, the milling practices in that particular region or country, and the type of equipment that they use. So as an example, I'm part of a Facebook a laminated dough group where we discuss croissants and things like that all the time. And when people have a problem, the first question we always ask them is, "What's your formula? Which flour are you using? Right? Do you have flour specs?" Because wet and dry protein is to clarify for those who don't realize, is that protein in North America is measured on the basis of a 14% moisture flour, whereas in Europe, it's measured on a dry basis. So it tends to be a higher value in that. So something like an 11% protein in North America might be a 12.5 or something in Europe, right? Um, so, but the other thing with that is that high protein isn't everything. It can be about the stability, about these are the things that you measure with the Farinograph and especially with the Mixolab on something like crackers in particular, because crackers are something that are laminated, and that is they're sheeted out and layered. Not like a croissant, they don't laminate fat in between, but it's just capturing air between the layers, and then so that they puff up and flake just a little bit. And so it is more to do with establishing the type of protein quality you need for a cracker rather than simply a protein number, right? Soft wheat flour in Canada, for example, in the milling industry and the baking industry, is referred to as cookie and cracker flour. It's used primarily for cookies and crackers. You would not use a hard wheat flour for crackers, or you would get a very tough cracker that's not very flaky, right?
Very interesting point. So when we heat up the dough, we are able to see how the gluten reacts to this increase in temperature. And this, if you think about the process, when do you heat the dough in the process is when you put the dough in the oven. If we take the example of a biscuit, for example, if the proteins do not resist very well to the increase in temperature, you may have a cookie spreading that is more intense than usual, and so a diameter that will not be good in the end. However, if you have a protein that reacts that is very resistant to the increase in temperature, it may not allow the cookie to spread so well. In the end, you have issue with the diameter. And that's a little bit the same thing, whatever your final product. If it's a bread, it can collapse if it's too weak. It can not grow if the proteins are too strong. But the point is that you are able to see this aspect of gluten when you heat up the dough. And then you are also able to see the starch functionalities. And again, starch is 70% of the flour and is mainly not controlled. And here, in the context of a dough, you're able to see gelatinization, which impacts the structure of the crumb. You're able to see the impact of amylase activity and to see how the starch retrogrades, which is very important for the shelf life.
Absolutely. I mean, and this is, again, it's really critical. So glad that we've touched on the gluten-free part, because not only because of such a growing market trend, but I mean, it helps alleviate a lot of challenges or unpredictability and things. Because, when you mention cookies, as in a traditional cookie, we tend to primarily look at sugar and fat as what affects the spread. But if you make a change somehow within the matrix, it's cookie is of course a big complex system, but how that starch reacts to that system is what changes so much. And a small change like adding lecithin all of a sudden can change everything. And if that starch doesn't gelatinize quickly or well enough, then you're going to get a lot more spread, even though you didn't change your fat or your sugar. So it affects all these different things. So it's really interesting information, very, very helpful on things like that.
It's very important, because gluten-free is all about starch, basically.
Yep, absolutely.
So this works exactly as usual. I guess you maybe already own the instrument and now you're looking to use it at full potential. Maybe here to start, I would recommend that you contact us to get all necessary information. But very quickly, it all works the same as usual. It's just that you don't put the nozzle on top of the mixing bowl when you start the test, because you don't want to inject water into the already made dough.
But
I
had a conversation with Arnaud Dubat recently, that we just launched a podcast, and one of the key things that why I encourage you to contact KPM with these things, because KPM Chopin are really in the business these days of being solution providers, right? And they really want to assist you. Their first goal is they want to assist you and help you provide the knowledge and the working ability to make good products. And if selling you a piece of equipment that fits into your system works, great, they'll do that too. But the main thing is, let's understand what you need, and I really appreciate and enjoy that about KPM for sure.
First thing first is, here you don't need to be highly educated to have like 4 PhDs on flour to understand what's going
even
on.
I could figure
And the
it
idea
out.
is not even to understand what's